When a scout bee has been dancing too long for a site that isn't good enough, another bee headbutts her. Not aggressively, not violently. A brief, precise contact, head to thorax, lasting less than a second. The dancing bee stops mid-waggle. She walks away. Her campaign is over. This is the stop signal. It is how a swarm of 50,000 bees prevents a bad decision from gaining momentum. Not through deliberation, not through authority, but through bees physically interrupting other bees whose data no longer justifies continued advocacy. There is no committee weighing the options. There is no authority with override capacity. There is only the dancing, and the interruption of the dancing, until the entire swarm converges on a single answer that none of them held individually. What that process produces is something researchers who study collective decision-making have spent years trying to understand. The swarm near your garden this spring made its decision this way. So did every swarm for the past 50 million years. The queen did not make this decision. She was carried to the outcome. And the scouts who ran the process that decided where 50,000 bees would spend the rest of their lives, most of them were dead before the swarm ever arrived. Here is what actually happened in the swarm that formed near your garden. And here is why understanding it changes what you think is possible without a leader. If this is the kind of thing that makes you reconsider what intelligence actually requires, subscribe. New video every week. Stay until the end, because what the scout's 6-week life means for the decision she made is the part I have not been able to stop thinking about. Most people who have seen a swarm assume the queen is at the center of it, directing the movement. The image is intuitive. The colony has a queen. The queen is the colony's organizing principle. When the colony moves, the queen leads it. The queen does not lead the swarm. She does not know where it is going. When a honeybee colony decides to swarm, to split, with roughly half the colony leaving with the old queen to establish a new hive, the queen's role in what follows is almost entirely passive. She stops laying, loses weight over the course of several days, becomes capable of flight for the first time in months. When the swarm departs, she is surrounded by a protective envelope of workers and carried along. If she lands, the swarm lands with her. She is not navigating. She has no information about potential nesting sites. She has spent her entire life inside the interior of the hive. She does not know which direction to fly. The swarm cluster, the hanging mass of bees, typically the size of a football attached to a tree branch or garden wall, waits. It can wait for hours, sometimes for days. It waits because the decision process running on its surface is not finished yet. The bees who know where the swarm is going are the scouts. A small subset of older workers, perhaps a few hundred out of the entire cluster, who have been ranging outward in all directions, covering several kilometers, entering every available cavity they can find, and returning to compete with each other for the colony's attention through dancing. Have you ever stood near a swarm cluster and noticed certain bees moving in short, purposeful runs across the surface of the mass? Those are scouts returning from their evaluations. The decision is already in progress. The process begins before the swarm has even left the parent hive. In the days leading up to swarming, scout bees start ranging widely, entering natural cavities, tree hollows, gaps in stone walls, spaces beneath roof tiles, and evaluating them against criteria so consistent across colonies that researchers have been able to measure precisely what a bee considers an ideal home. The cavity volume should be between 20 and 40 liters, large enough to store sufficient honey for winter, small enough to be thermally manageable through cold. The entrance should be small, positioned near the bottom of the cavity. It should face away from prevailing wind, be dry, protected from flooding, free of existing occupants. A scout runs through this evaluation with a thoroughness that surprised the researchers who first documented it. She inspects the interior, walks the walls, assesses the entrance from both sides. The inspection of a single cavity takes several minutes. She is not sampling,
She is measuring. When she returns to the swarm cluster, she dances on its surface. The same waggle dance that Carl von Frisch decoded. Direction and distance to a resource encoded in the angle and duration of a vibrational run. Here the resource is not a flower. It is a potential home.
And here is the critical mechanism. The quality of the site is encoded in the intensity and duration of the dance. A scout who has found an exceptional cavity dances for longer, with more repetitions, more vigorously. A scout who has found a mediocre cavity dances briefly and stops. There is no deliberate exaggeration in either direction. The dance intensity is proportional to site quality because the nervous system generating the dance responds directly to how good the cavity was. The enthusiasm is not performed, it is produced. Other scouts watch. Some follow the dance to the advertised location, evaluate it themselves, and return. If they agree it is as good as advertised, they dance for it with equivalent intensity, adding their voices to the growing argument. If the site is less impressive than the dance suggested, they dance less, or not at all. What this means is that better sites naturally accumulate more advocates. More advocates recruit more inspectors. More inspectors, if they agree, produce more advocates. The process is self-amplifying in proportion to quality and self-dampening in proportion to mediocrity. No scout ever had access to information about all the sites being evaluated simultaneously. Each one only ever knew what she had seen. The collective picture emerged from the sum of individual assessments without any individual holding it. And through all of this, the queen hangs in the center of the cluster, waiting, going wherever the result turns out to be. In 2010, a researcher named Thomas Seeley at Cornell University published the most complete account of this process ever documented. The book was called Honeybee Democracy. The research behind it drew on decades of field experiments conducted on a small island off the coast of Maine, where there were no natural tree cavities, allowing Seeley's team to place artificial nest boxes in precisely known locations with controlled characteristics and observe which sites swarms chose and how. What Seeley established about the mechanism of consensus was more specific and stranger than anyone had previously determined. The swarm does not lift off when a majority of scouts are dancing for the same location. It lifts off when a quorum threshold is reached, when approximately 15 bees are present at the chosen site simultaneously. Not a majority, not a committee-sized group. 15. In a swarm of 50,000 bees, 15 individuals registering their presence at the same location at the same time is sufficient to trigger the entire colony to move. Seeley found that this threshold represents a precise evolutionary trade-off. A lower threshold would produce faster decisions, but more errors. The swarm would commit before adequate evaluation had occurred. A higher threshold would produce more accurate decisions, but dangerous delays. A swarm cluster has limited food stores and limited time before weather or predation becomes a critical problem. The 15-bee quorum has been tuned by selection pressure across millions of swarming seasons to balance decision accuracy against the time cost of delay. The stop signal, Seeley documented, adds a second layer of precision to the system. As consensus forms around the winning site, scouts from the leading location actively suppress advocates for inferior alternatives, not by argument, but by physical interruption. The mechanism the Hook described. It works because scouts who have seen the best site are more numerous and more motivated than those still campaigning for second choices. A forming majority does not wait for the minority to give up. It stops them. Intensity defeats persistence. What Seeley found across hundreds of documented swarm decisions was a system that chose the best available site in the vast majority of cases. Not the closest site, not the largest site, the site that best matched the full set of criteria. A site no bee had collectively discussed, agreed on through deliberation, or been directed toward by any authority. Seeley spent decades documenting a process that had been running, reliably and precisely, for longer than our genus has existed. Right now, somewhere within 5 kilometers of where you are sitting, swarms may be forming.
The colony that has been sending foragers to your flowers since the first warm weeks of the year is at its peak population in late spring. Colonies that have grown beyond a critical size trigger swarming preparations. The rearing of new queens, the gradual reduction in laying, the scouts beginning to range. When the swarm departs, the cluster will hang somewhere close, a tree in your garden, a wall, a fence post. And from that cluster, scouts will radiate outward across the full range of their flight capacity. Your garden is within that range. Your garden may already have been visited by a scout who was not interested in your flowers. She was interested in the structure behind your garden wall, the hollow in the apple tree that has not been cut back in 3 years, the gap beneath the ridge of your shed that you have not looked into. The swarm will lift off when 15 scouts reach quorum at a single location. It will rise from the cluster as a coherent mass, 50,000 bees becoming a single moving object, and fly at approximately 30 kilometers per hour in the direction the winning site scouts steer it toward. The scouts guide the mass from the outside, flying faster than the swarm's average speed through the edge of the moving cloud to direct it. The queen, in the center, follows the steering she cannot see. Within hours of arrival at the new site, the colony begins building. Wax is produced and shaped. Comb is drawn. The queen resumes laying. The scouts who found the site will be dead before the first winter. They will never carry honey from the stores they helped establish. The home they found is not for them. They found it anyway. I want to tell you something about the scouts who made this decision. A scout bee who participated in the consensus process did so in the final weeks of her life. She emerged from her cell, moved through the sequence of tasks every worker bee follows, cleaning cells, nursing larvae, producing wax, guarding the entrance, foraging, and reached scouting at around 3 to 4 weeks old. She has 2 to 3 weeks of flight life remaining. She will be dead before the colony she helped preserve has built its first season of stores. She will never see the winter she chose a home for. She danced for the location anyway. She inspected the site, assessed its drainage and its entrance geometry, measured the internal volume, evaluated the orientation. She danced for it on the surface of the swarm with an intensity proportional to how good it was. When competitors advocated for inferior sites, she found them and stopped their dancing. She flew back and forth between the cluster and the cavity, adding her presence to the quorum count until the threshold was reached. And then the swarm lifted off toward a home she chose and would never live in. The system she participated in is not designed to serve any individual within it. It is designed to serve the colony's continuity across time, across winters she will not see, across seasons she will not experience. The decision she helped make will shape the survival of a colony that will continue for years after she is gone. No one designed the quorum threshold of 15. No one designed the stop signal. No one designed the proportional enthusiasm that makes better sites accumulate more advocates faster. Each element emerged from the accumulated record of every swarm that found its home in time and every swarm that didn't. The design is not a design, it is a residue of survival. Right now, while you are watching this, a bee on a flower in your garden belongs to a colony that has been solving the problem of collective decision-making for 50 million years. She doesn't know this. She just knows the route from the hive to your lavender and back. But the problem was solved in the hive she came from. It has been solved every spring without a single failure of the underlying mechanism, without a single modification to the quorum threshold, without a single leader appointed to manage the outcome. The swarm near your garden this season is not a problem. It is a democracy in session. Seeley, after decades of study, describes the accuracy of swarm decisions in terms that make uncomfortable. Reading, if you spend time thinking about how most human groups make consequential choices. The bees, without a leader, without a vote, without a single individual holding the full picture, get it right. Almost every time. I find I cannot watch a swarm cluster hanging in a tree the same way anymore. What looks like stillness is 50,000 bees in the middle of something extraordinary. Tell me in the comments, have you ever seen a swarm? And if you have, did you know at the time that what you were looking at was a decision process in progress? That the cluster hanging there was mid-vote? Tell me what you thought was happening and what you think now. I read everything. Subscribe. New video every week. See you next time. And if you want to understand how the colony that produced that swarm knew it was time to go, before a single bee had left, before the queen had stopped laying, before the scouts had begun ranging, that is the next one.